Hi, I'm Ed Sperling. I'm the editorial director of Low Power High Performance Engineering. I'm here with Bernard Murphy, the Chief Technology Officer at Atrenta. Bernard, we just got back from DAC. What did you see that was different this year?
Well, I think it was a very interesting show this year. It was a very good show for us. I found something to be kind of curious about DAC 2012. I felt this was much more a design enablement conference than a design automation conference, at least on the show floor.
What does that mean?
So if you think about traditionally, design automation conference is focused on a lot of design automation tools, so physical design tools, simulators, synthesis tools, and so on. This felt more like a conference that was focused on the whole process of generating a design from concept to package delivered silicon. So I saw, of course, TSMC was very big there, and actually we were presenting in the TSMC booth. I saw, of course, Global Foundries was there as well. I saw a number of small silicon services companies, small ASIC companies. I thought was very interesting. People who are going to take your RTL design and finish it through to a foundry. ARM was very big there. I thought that was interesting because ARM is very much an IP provider, not traditionally associating itself very much with Design Automation Conference. Xilinx was there, as was Altera, very much focused on FPGA solutions, and actually Atrenta was presenting as part of the Xilinx Vivado flow. In the ARM connected community, we were presenting our early PPA, power, performance, and area solution. And of course, generally, we were presenting our solutions for making IP libraries more robust, higher quality. I saw Sonix and Arteris there presenting their bus fabric solutions. So in general, I saw a very big focus more on all aspects of completing and delivering a design and not just on the tooling, if you will.
What's driving this? Is it complexity? Is that really the driver of what's changing here?
Interesting question. I think for certain IP, prepackaged and pre-verified IP is a way to manage that complexity, and that's very much why you see, of course, ARM and also some of the bus fabric and other providers. So that's certainly a way to manage the challenge. I think the complexity of managing deep submicron is why you're seeing TSMC and Global Foundries there. I think the cost alternatives are why you're seeing Xilinx and Altera there. So yeah, I think it's difficult to decouple this problem anymore into just the design tooling versus the manufacturing and so on pieces.
Power was a subject of a lot of the sessions this time at the conference. How much of a problem do you see that going forward? Have we solved it, or will this continue to be a problem?
I think power is huge. Roll on the day when we can say that problem is solved. I don't think we're there yet. We had huge attendance in our suites, and what was very interesting is that we have tended to think as an industry as power, which is a problem which is dominated by mobile applications. And we were really starting to see the group of people who are interested in this is expanding significantly. We're seeing people who are looking at server applications becoming much more power sensitive. Base station applications are becoming more power sensitive. So of course, to varying degrees, they're not all trying to do what the mobile guys are doing, but they're all having to focus much more significantly on this domain. Huge attendance.
Part of that is strictly a cost function for them, right, as opposed to saving battery. In a data center, for example, it could be millions of dollars that could be saved.
Well, absolutely. It's cost in differing ways, of course. In a data center, you're talking about whether you have to run giant cooling fans and refrigeration units, and those have their own costs, and frankly, just square footage. that you have to assign to something like this. For base stations, you're talking about units that are sitting quite literally out in the wilds, up on mountaintops, and so there are costs associated with those, which are of course very different than battery costs, but very real nonetheless.
Where does that leave the equation of power, performance, and area?
I think there's something of a feeling, and maybe I'm going out on a limb here, that area is perhaps a little less of a driver now. You can jam a lot of transistors onto silicon at 22 nanometers, but power and performance, performance actually in some ways in the mobile applications is not a super strong driver until you get into things like streaming video and applications like that. Power is a very, very strong driver, and it directly affects cost as much as battery lifetime.
Are we going to see even more pieces coming into this as well? Think about software, for example.
Absolutely. I think that is absolutely inevitable. If you are building a system, you want to see all the components that are going to help you optimize your system on one show floor. And just looking at the parts that go together to build one piece of silicon is not going to be enough.
One thing that I heard repeatedly at DAC was that everybody that works on chips and on electronics is surprised the stuff works. There are so many different pieces that go together, so many different problems that can erupt, and so many bugs that potentially can come into these devices.
Yes, that's that's certainly an interesting domain. I think there were a couple of interesting verification companies on the floor, Nextop and Brecker. I was listening to a very interesting presentation at the Brecker booth saying that the view that you can get through verification with directed random simulation in some form is breaking down, and that you really need to start moving towards higher level test benches that are software driven rather than, or software centric rather than hardware centric. I think that's absolutely true. I think there's going to be an increasing focus on emulation based verification and tools that more enable emulation based verification around assertions, these software test benches, if you like. All of those are going to be important.
So as far as you're concerned, we're all going to have jobs for a very long time.
Absolutely. I think we're very, very safe.
Bernard Murphy, thank you very much for your time.